Hi, in this video I will go over valid anagram. It's a Leetcode easy problem, and here's the problem statement. So we're given two strings, S and T, and we want to return true if T is an anagram of S, otherwise we return false. So an anagram is basically a word. Let's say race, we have race as S, and then our T was care. Right, so we're given two strings. These two words are anagrams because they contain the same letters and the same frequency of those letters. So we have R once, A once, C once, and E once. So an anagram is basically a word, and two words are anagrams if they have the same letters and number of frequencies for every letter. So the order really is what makes it tricky, because like you can't really tell if the words are anagrams unless you compare them. So the first step I like to do is analyze the input and output. Alright, so we are given two strings, and we want to return a boolean. So some ideas I have thinking about this problem is, what if we sort the strings, right? So back to our example, race would be sorted by alphabetically, so A and then C and then E, I believe, and then R, and then care. If we also sort this string, we would end up with the same order. So given those two strings, if we basically just sort them, then and then we compare them and they're equal to each other, then those are anagrams. And this would be like my brute force solution. Now, thinking about the time and space complexity, well, for time, sorting, let's say use the sorting function in C++. If we assume that it would take big O of n log n in the best case with no extra space, then this would be our solution. But if we would like to find a more optimal solution in terms of faster time complexity, then we would have to trade off basically the space for that. So our optimal solution would be using a data structure. Right. So in the beginning, I mentioned that every character is going to have, it should have the same frequency in string S and string T for them to be anagrams, right? So using a map would be helpful in this case, because in a map we store key value pairs, right? And let's say we had a map here. For this example, we are going to basically go through each character and then add it to the map with its frequency, right? And then keep updating. So we start with, remember we had race. As we go through it, we're gonna add R frequency 1, A frequency 1, C frequency 1, and then E frequency 1. Right? And then if any character was repeated twice, then we simply just update its value, because when inserting into the map, a map keeps a set of unique keys, so it would just update the value. So this was our map for the first string, right? String S. Now, how would we know if the other string was also an anagram of this? Well, we can also create a map for the other word, and this would look like this. We start with C, is 1, A is 1, R is 1, and then E is 1, right? So now we have two hash maps with the characters and their frequencies. And simply by comparing those two maps, we can get our solution. If those two maps are equal, then the two strings we have are anagrams, otherwise we return false. So let's go over the code in C++. So this is our function, is anagram. It's going to return a boolean, as we mentioned, and going to take in two strings. So first thing I did was initialize two unordered maps. Each map's going to have a character as their key and an integer as their value, representing the frequency. So we have a map for S and a map for T. Now, I added this base case in my approach where if their sizes are not equal, we just simply return true. This is because there's no way we can have two strings as anagrams if they don't have the same length, right? So race and then car wouldn't be anagrams because this is 3 characters, this is 4 characters, so there's no way. And this also helps us like adding them to their maps in one pass, basically. So what I'm doing here is I have a for loop that's going to run from 0, and then we take the size of S because they're basically the same size, right? So in race we had 4 characters basically, so we're going to have from 0 till 3 iterations, so 4 iterations. And in every iteration, S map, we are inserting the character so into the map this way, and then the plus plus is basically setting the value, right? The integer value. So S map, S of I is the character at the ith index. In race, that would be this in the first iteration, and then its frequency would be, initially it would be 0, but then plus plus it would be 1, right? And then if this was repeated, then the plus plus is nice because it just updates the frequency for the same key, right? So this is like maps, right? So we're indexing kind of into the ith index and then updating its value. And similarly, we can do this for the map in one pass. And here it's very nice because you can simply just compare the two maps with each other, and if they're equal, you return true, otherwise you return false, and this makes our solution very simple and easy to understand.